So we can factor that, right?
Yeah.
1,000. Is this finished?
No. Yeah, Christy. Well, the 900.
Okay.
1,000 plus 900.
I think this is a good time to pause and check. What do you think?
I think that's
Yes.
I know that 3,000 plus 2,700 is 5,700. That's
Yes.
check.
Yeah.
Okay. A check. 3 times
1,000.
is 3,000.
Yeah.
So is this tree branch done?
Yes.
Okay. So
Wait.
check.
Check.
Is this tree branch done? 3 times 900 is...
Yes.
All right. Now I'm doing something that I don't like to do. Guess what? As I'm bringing down my math applications, I have an add sign and a multiplication sign. I'm starting to turn that symbol, and I'm starting to question, is that a multiply or an addition sign? Okay, Mrs. Bors, please make it nice and neat so the students don't get confused. And likewise, I know you'll respect me when you turn your paper, so make sure everything is real straight and neat so I don't confuse an addition sign for a multiplication sign, right? Okay. Well, I'm just saying in general, everything's going to be nice and neat and legible, right? Okay. So, 3 times 1,000 is 3,000. 3 times 900 is 2,700. Is this branch done?
Yes.
Okay.
Wait, no.
Yes.
Because our central question is what? What are we, go back to the top, what are we trying to find out?
5,700 divided by 3.
5,700 divided by 3. Do we know, at the tip of this branch, have we figured out and factored out the 3?
Yes.
Stop. Now, what is my final answer?
1,900.
1,900. Because I'm doing 1,000 plus 900.
I know, I got that. Because they're both divided. If you can add them, as long as they're both divided even, as long as that number is
That was easy. That was very easy.
Yeah, it was.
Does everybody understand branching?
Can we
do it by four?
Can we do what?
Can
we do it by 4?
We can do it by 4.
No.
Can we do it by
It's not
4?
going to be divisible, though.
Why not?
Oh, yes.
What would be our test to see if it's divisible by 4?
Oh, wait.
Well, what does the number have to be?
Yeah, but
It's 12, so 4 can go into 12 3 times, so it would work.
But that's the rule for the number 3. That's not the rule for number 4. 4 has the same rule as 2, does it not?
Even numbers.
Even numbers, maybe.
it ends in a 0.
Maybe. We know that 2 goes into this number, yes?
Yes.
Yes.
We know that 4
2
also possibly goes into this number, but we want to check it out. We at least know that 2 is a factor of 4, so we can get there by doing what?
Wait, how does 2 go into that?
2 goes into 5,700 evenly, yes? Because it's an even number. Oh, Kelsey. It's an even number. Oh! Okay. But 4, let's test it out. I like it. I like the challenge. Oh, no. A wise man once told me that if you all are exhausted by the end of class, I have definitely done my job. Okay, so divided by 4. Branch it. Everybody work quietly to themselves. All right. You're not ready to be released yet. All right, let's go. What is a friendly number to divide by 4 out of? What is 5,700 made up of? What's inside of that? To get 4,000, that's even. Plus what? 1,700. Love it. Okay, this is easy. Divided by 4, 1,000. Everybody with me?
Yeah.
Everybody with me? Okay, 1,700.
But when you get...
What should I do with it?
You should do another branch and do 1,200 and
Yeah, 1,200 is a good number. Is that friendly? Friendly divisible by 4? Okay, I like it. She says 1,200. What's left over? 500, she says, with certainty.
No, was it
I like your conviction.
Or no, wait.
Add it up. Kelsey brings up a good point.
No,
This is a wonderful time for a
No, I thought it was 8.
check, right? Let's pause and check. Kelsey, we're checking. Thank you for reminding us. So, we know that 4 times 1,000 is 4,000.
Yes.
We know that 1,200 plus 500 is 1,700. And we know that 4,000 plus 1,700 is 57.
4 and 300.
300. You guys are very good at math.
Would it be 400 and 300?
No.
Kelsey, relax, breathe.
Oh, never mind, I get it. Okay.
What math application do I want to put here?
Oh, time. Oh, that
She
makes
says
a
with
lot more
conviction
sense
and
now.
certainty. She knows what she's doing. All right, next, 500. How do I want to factor that out by 4? Ben, talk to me. You've been very quiet today.
Here to inventory.
How?
Yes, sir.
400 and 100?
Yeah.
That works for me. I like it. 400 and 100. Ben, what math application am I putting between these two?
Addition.
Thank you, sir.
Oh.
As opposed to multiplication. Now, 400 and 100. What is 400 divided by 4, Ben?
Sure. And the other one, there's one right here. I think all the two
This?
All right.
Yeah.
Thanks a lot. Sure.
Sorry, I didn't
Fine.
hear you. Okay. What should I do with 100? Does 4 go into 100 evenly? Is that friendly to you? 700. At this point? 4. 4 goes into 100 how many times? Very good. Ben, what kind of math application am I putting in here?
Multiplication.
Thank you. Here? Alrighty. Is my tree branch complete on this side? Matt? Yes? Okay. What is my, Sebastian, do you have my addition statement to come up with my factor to answer my problem? 5,700 divided by 4? Do you know what I should do now? What should I add up? You guys help him out a little bit if you want.
Wait a minute.
I know Sebastian's a deep thinker. I know he's on this. He likes a good puzzle now and then. We'll let you work with it. Do you want to answer it? Do you want me to? Okay, point out everything. What am I going to add up first? Give him a minute.
400 and 100.
Okay, well wait a minute. We're going to the tip of our tree. This is one tip. And the tip of our tree represents the final factoring. And when we come up with our factors, we add them all up. That's the point of branching. So the 4 is what we're dividing by. So we are going to take the other branch and add it to the other items to come up with our total factor. So what am I adding up, Sebastian? 1,000 plus
300.
plus
100.
plus.
25.
Very good. Can I just put that together here?
Yes.
Is that messing anybody up? You get what I did? I did 100 plus 25. Thank you, Sebastian. Do you know total?
No.
All right, everybody read it together. 1,425. Oh my gosh, that is a hard problem. Thank you for bringing that one to our attention. Would you have been able to solve that in your head?
No.
Is branching a little bit more visual for you? Is it easier than the logarithm of the divisor and the dividend and all that stuff? Is it the old-fashioned way? How many of you prefer the old-fashioned division algorithm?
Many there.
As opposed to the branching?
Yeah. Exactly.
All right. That's very interesting. If you guys want to, and if you eventually start taking in middle school other math subjects, this is a valuable tool to let you understand the different components of a number, and sometimes those are things you need to know. So it'll be a tool you have in your pocket, and you can pull it out when you need it. But do it the way you prefer, because you'll always be accurate. Yes?
I like this way better, but the algorithm is faster.
It just depends.
Yeah.
When you get into larger numbers, in the millions and the hundred thousands, you might find that doing this on the side is going to be a quick trick for you.
It will take up so much right now.
Well,
Yeah,
you can make it, yeah, it just depends. When you start doing algorithms and you're doing your divisor, the very important component is to bring your numbers down accurately and to keep your value places lined up and stacked up. 95% of errors are made because people start sliding things around and they don't stack things up.
Lacey, you have to turn it up and make it smaller.
Yeah.
And there's two right here.
May I show you a
There.
picture?
See how just.
So here's an example of how you can contain it so it's not that hard. The other thing that this factory
But they're here,
does
that's a good thing.
is it strengthens your math facts because it's constantly checking your math facts,
Thanks a lot,
and
man.
eventually your brain starts thinking through it faster, and by the time you're in 8th grade, you're going to be doing this in your head. And that's what's fun. When you can do mental math in your head, you start looking genius level. And maybe you don't even like math, but it's fun. Okay? So, now, let me ask you this. The magic wall of threes. If I gave you a number 2,310, is that divisible by 3?
Well, it's got 3 in it.
2,310.
I think we're good,
Why?
man. Thanks, bro. Appreciate it.
Sure, no problem.
Yeah.
2,310. Well, you can just use a digit number. Instead of 15, just make it 2,310 is 2, 3, and 1. Equals 6.
Yeah.
Same difference.
Oh, can you add up all of these to get your...
Yeah.
If you add up the digit,
So
if you add up all the digits in the number.
1, and then the 0 is like less, and then 9 equals 6.
okay, you're confusing the digit value versus the place value. Don't worry about it. That's
Okay.
right. Okay. We'll take you there. I can work you on this. I can work with you on the side if you have any questions about that. So, Mr. Byer,
Yes,
we're on
ma'am.
early release today. How many minutes do I have left in this class?
About 3.
Okay. All right, so tomorrow, if we have time, we are going to go through the exercise of figuring out what the better deals are. And the reason why I want you to be able to do tree branching is because I want you to be able to factor out prices of goods. We're going to compare quantities and look at the sale. Like you have a coupon for 50% off at Target, but Publix lets you buy the same thing, buy one, get one free. Which is the better deal?
It depends on how much the buy
It's
one
not
get one free
always
costs.
So, wait a minute. Raise your hand one at
You're
a time.
buying it for half.
Go ahead.
It depends on how much the buy one get one free costs. Because if the buy one get one free, if it costs like if the one costs a ton, then the other one might be a better deal.
In fact, I've put together some exercises that it doesn't even have to have a big difference in price. It could be as much as 3 cents difference. And one deal is better than the other.